Hello students. Let's do some factoring using the CPM algebra tiles. Now, why do we use the algebra tiles? Why do teachers suggest that you use algebra tiles to perform factoring? Well, algebra tiles are a good way to visualize quadratic equations as geometric objects. It gives you some intuition about the, the symbols behind the quadratics. So if you just see something like this equation here, x squared plus 7x plus 12, it just looks like a bunch of symbols. But if you think about another way to imagine x squared plus 7x plus 12, you can imagine each one of the terms of this equation, these three terms, being geometric objects. So let's do that with algebra tiles. And when you do that, there are certain options that arise from certain benefits that arise from imagining a quadratic geometrically. So let's begin by sort of organizing our algebra tile screen. Click on, well, first of all, go to the website itself, technology.cpm.org/general/tiles, and you can pause the video and load the website. When you get to this website, click on backgrounds and choose the corner piece background. And the corner piece background places this little kind of a mat on your desk, on your desktop rather, your virtual electronic desktop. So the importance of this is that down here in this area will be one factor of the quadratic when we're done factoring, and the other factor will go along this part of the mat when we're done factoring. And of course, our entire quadratic will fit inside of this area here. So I'm going to actually erase what I just added right there using the fancy erasing tools of this video editing software. I wish there was a way to just delete it all, but I guess I'm going to have to draw a line all the way through that. There we go. So let's do some factoring by taking a look at x squared plus 7x plus 12. So we first need to assemble all the geometric pieces. One of the x squared, 7 of the x's, and 12 of the 1's. So under the algebra tiles screen, tap algebra tiles and drop one of the x squareds and then 7 of the x's, 1, 2, 3, 4, 5, 6, and 7, and then 12 of the 1's, 1, 2, 3, 4, and I can copy these, Control C and Control V, Control C and Control V. Should have 12 there now. So all of these scattered loose objects here, when you add up the area of each one of these together, you get x squared plus 7x plus 12. There's the x squared. There's 7 of the x's. 1, 2, 3, 4, 5, 6, 7. And then there's 12 of these 1's. Kind of intuitive when you think about the quadratic as a geometric object. And I'll line them all up here, and maybe I could do something like put them in 2 rows of 6, just for the heck of it. Just trying to keep them close to each other. Makes them easier to move around. So our challenge now is to make a rectangle out of all of these objects, all the 1's and all the x's and all the x squareds, which is just 1 x squared. We've got to make these into some kind of a geometric object. They need to be made into a rectangle, specifically a rectangle. So anchor any part of the objects in the lower left-hand corner of this corner piece mat. And now Mr. M over here is going to try to make a rectangle out of this. And I have not factored this before, I promise. And I'm just going to see if I can make a rectangle. Well, that's not a very convincing rectangle right there. So it's going to take me a little while to do this. You might have to speed up the video to watch me do this. Yeah, that's not going to work. That doesn't look very good. And how about if I did something like maybe rotate it? I think if I line these up, they line up pretty good. But then I have a problem with this thing right here. can I take that? If I double click on it, it rotates it. How about if I move this over like this? I'm getting closer. Can I rotate that around? But now I don't quite have what I need because this is not a rectangle. So I've got to somehow make a rectangle out of this deal. It'd be cool if I can just take those two things away. But I can't. I have to leave them there. How about if I took one more of these and then tried to move this? Oh, did I just get lucky? I think I got lucky. Oh, look at that. I got a rectangle. Okay, so notice now what the dimensions of this rectangle are. And we measure the dimensions down along the bottom here. We measure the dimensions in this direction. And we measure the directions. I'm going to change the color here. Check out Mr. M with the fancy colors. I'm going to change the color, and here. We measure in both of these directions. So what are the measurements of this rectangle? So down here, what is that? That's x. And how wide is this? That's just 1 unit. And that's also 1 unit. And that's also 1 unit. And that's also 1 unit. Now likewise, along the vertical axis, we have something which is also x units tall. This is also 1 unit tall and 1 unit tall and 1 unit tall. So along the bottom, it looks like we have x plus 4. And along the top, it looks like we have x plus 3. So those are the dimensions of this quadratic. It's x plus 3 tall, and, oopsie daisy, it's x plus 4 wide. This is the length, and this is the width. And as you know, width times length is equal to area. And so x times 3 multiplied by x plus 4 adds up to everything on the inside, which would be x squared plus 7x plus 12. And you can see that again when you do the distributive property and multiply these two binomials. X times x gives us x squared. X times 4 gives us 4x. 3 times x gives us 3x. And 3 times 4 gives us 12. Now when you add all this stuff up, you get x squared plus 7x plus 12, which is exactly the quadratic that we started out with. So this is how to create an algebra tile factoring of a quadratic. You arrange the individual pieces into a rectangle and you figure out the dimensions of the rectangle. That's the general approach.